Question from aldehydes, ketones, and carboxylic acids. Which product is formed when the compound benzaldehyde is treated with concentrated aqueous KOH solution? So we can see that this is the Cannizaro's reaction. Benzaldehyde is a compound which does not have alpha hydrogens. And Cannizaro reaction takes place in aldehydes without alpha hydrogens. Alpha hydrogen means if you have a say carboxylic group like the CHO group like this, carbonyl group, then you have a carbon attached to it. This is the alpha carbon, and if you have hydrogens attached to this, you call it alpha hydrogen. So in benzaldehyde there is no such thing as alpha hydrogen, because this is the aldehyde group and attached to it is this carbon. There are no hydrogens attached to it, only other carbons. So this compound can undergo Cannizaro reaction. So is formaldehyde, CHCHO. Here there is no alpha carbon itself. So there are no alpha hydrogens also. So this will also undergo Cannizaro's reaction. So let us just look at the mechanism. Say we have a benzaldehyde molecule like this, C double bond OH. Now this is in a strongly basic medium that is given in a question, that concentrated aqueous KOH. So OH minus is there. This OH minus will come and attack the carbon here. As a result, this bond will break and the electrons will move up there. Now you will have CO minus, and here you have this H, and this OH will come and attach here, OH. Now there is another benzaldehyde molecule. So on this I have C double bond OH. Now this is a very unstable ion, an alkoxide ion. So it will repel, or it will kind of send out this hydrogen as hydride ion. Now that hydride ion will come and attack the carbon here. So there is a hydride transfer here. So what will happen? This bond will, those electrons will come back here, and these electrons will go up there. Now let us see. We will be having this with carbon, double bond O and OH. But this hydrogen is gone as the hydride, and you are having this benzaldehyde molecule with O minus and, sorry, it's not done that, carbon, O minus, and one hydrogen here, and the hydride ion which shifted from there has got here. So it will be like this. Now this is in a strongly basic medium. So what happens is that there are lots of OH minus ions here. So this will pull out a proton from here. So one proton is taken here, and so a negative charge will remain on the oxygen once that goes here. And what will happen to this OH minus? It will become HOH minus, and from this HOH the proton is taken up by this oxygen, O minus. So you will have, here you will have C double bond O minus plus, Here you will have COH and these two hydrogens, H and H here. So there are potassium ions as well because we are using concentrated aqueous KOH. So this can combine with potassium ions and this can result in a salt, that is the potassium benzoate, and this you can see is benzyl alcohol, that is CH2OH. So these are the two products formed. One is a salt, potassium salt of benzoic acid, and this is benzyl alcohol. So these are the products obtained. Here you can see that this molecule is letting go of a hydrogen, and so it is getting oxidized to the acid form, and whereas it is accepting the hydrogen and it is getting reduced as alcohol. So let us see our options. What we got are potassium salt of benzoic acid, that is here, and alcohol, benzyl alcohol. So option B will be a correct choice. Now about Cannizaro's reaction, just remember aldehydes undergo this reaction. Aldehydes without alpha hydrogen undergo this reaction. Then concentrated alkali, aqueous KOH or NaOH used. Same compound undergoes oxidation and reduction. So you call it a disproportionation reaction. That is, the products obtained are carboxylic acid and alcohol. Here we are getting a salt of the carboxylic acid, that is potassium benzoate. So option B will be the correct choice.